Hello everyone. In this video, we'll discuss about concentration terms, which is the important topic in this chapter, some basic concepts of chemistry. This is the chapter where it is an easy chapter, but we need to understand the question first, and we need to correlate all the concentration terms, whatever they are asking. Like we need to understand basically what they are asking, what we need to find, and how can we find that particular one through whatever the information they have given. So we can able to correlate. We have to correlate all those terms and things. So then it will be some sort of easy chapter. But yeah, first thing you need to understand all these things. Let's try to understand these concentration terms in this video. So first, what exactly these concentration terms means? It is a way of expressing the amount of solute which is present in a solution. Bus. Okay. So the concentration terms basically it is a way of expressing the amount of solute present in a solution. So the amount of solute which is present in a solution. Fine. This is basically a concentration terms. It explains how much solute is present in the solution. Alright. So now let's try to discuss different concentration terms. Okay, first we'll discuss about this molarity. Fine, which is denoted by capital M, and it is basically the number of moles of solute per liter of solution. In this definition, whatever I have told you, in this definition itself, the formula also lies. Let me write the formula directly. So what I have told you, it is the number of moles of solute per liter of solution. है ना? Here, the number of moles of solute per liter of solution is divided by volume of solution. Fine. This will be in liters. If they gave an ml milliliters, you need to multiply with 1000. Fine. So you can also write it as number of moles by volume in liter, or you can just keep L. Okay. Yeah, volume in liters. So this is the molarity, and then next concentration term we'll discuss about, which is molality. Molality. Just don't get confused between these two terms. This is the molarity, this is the molality, fine. And here, this is the small m, है ना? Yeah, this is small m. And here, this is the number of moles of solute per kilogram of solvent. Here, we have talked about volume of solution, right? Here, it is the number of moles of solute per kilogram of a solvent. So, the formula is number of moles of solute by mass of solvent, which is in kgs. Okay, mass of solvent, which is in kgs. So mass of solvent, which is in kgs. You can write the formula this way: number of moles by weight or mass of solvent in kgs. Fine. If they gave mass of the solvent in grams, you can just multiply this with into 1000. Fine. So these are the two concentration terms. These are the two concentration terms that we have discussed. Now let's discuss few more. Yeah, fine. Now let's try to discuss normality. Okay. So there is a relationship between normality and molarity. If they give molarity, we can able to find the normality if we know the n factor. I'll also explain here what is n factor and all. Right. So the formula of this normality is number of gram equivalents of solute per liter of solution. I'll write it over here. N is You just need to understand these formulas. Matlab, just try to remember in this way itself. Then it will be easy for you to solve the questions on questions also. Just don't remember like if it is a molarity, then W by GMW into 1000 or something like that. Just don't try to remember. I'll tell you what exactly the number of moles. For calculating number of moles, we'll be having two, uh, what you'll say. For finding number of moles, we'll have two formulas. One is given mass by molar mass, fine, or gram molecular weight, whatever. And one more formula for finding number of moles is this is only for the STP condition and only for gases. This is given volume by 22.4 liters. Okay, fine. This is at STP condition and standard temperature and pressure, and applicable only for gaseous system. Fine. These are the two ways that you can able to find the number of moles. So why I have told you this formulas means here in all these terms that we are getting the number of moles of solute and all, right. So in order to find that thing, you can use these two formulas. So yeah, now let's try to discuss this normality. Normality n is the number of equivalents or number of gram equivalents. It's fine. Number of gram equivalents by what? Volume of solution in liters. Solution in liters. Fine. So here is the thing is that you need to find what is number of gram equivalent weight also. I'll write all the formulas step by step. Fine. Don't get confused over here. Number of equivalents or gram equivalents is equals to weight or mass by gram equivalent weight. All right. So this is the number of equivalents. Number of equivalents is gram given weight by gram equivalent weight. Again here gram equivalent weight ka formula is atomic mass by n factor. So n factor is different for acids and bases, right? Number of H plus ions in acids, number of OH minus ions in bases, and the charge uh, this is how like I'll explain you about the n factor in a different video, separate video, fine. So this is the way that you can follow whenever if they give normality in the question, just try to correlate with this. So number of equivalents from this, what will happen here? We can also write this thing like this, you know? Number of, so this we can also write in this way, you know? Number of gram equivalence, or we can say simply equivalence. Fine, don't get confused over here. Equivalence is equals to normality into value of solution in liters. I have just uh, took this one denominator into the and multiplied with normality bus. Now, so this is just a I just rearranged this formula. So this is how you will find the number of gram equivalents through this formula. Given weight by gram equivalent weight. Again, for gram equivalent weight, we will use this thing. Atomic mass, whatever the atomic mass, we'll divide that with n factor, right? So this is the normality concept. And now let's try to discuss one more concentration terms, which is mole fraction. Mole fraction, which is a simple topic. So generally, the mole fraction of A, the formula we can write it as moles of A by total number of moles. Let's say two components are there, A and B. A is a solute and B is a solution, whatever. Total number of moles. Number of moles of A plus number of moles of B. And mole fraction of B is number of moles of B by total number of moles. Matlab you will just add it. So whatever mole fraction we want, that number of moles will be on the numerator and total number of moles will be there on the denominator. Simple, right? And one more thing, if you add it up, mole fraction of A plus mole fraction of B, simply 1. Right? So this is a basic thing. And one more, let's try to discuss even more concentration terms, which is weight by weight, percentage, these things. Percentage of weight by weight, like percentage of weight by weight. This is simple. What we'll do here, mass of a solute, here it is a weight by weight, like both sides it will be mass or weight of the, we can write like this, mass of solute by mass of solution, fine, into 100, as we are discussing about percentage, right? And the next one is percentage weight by value. Here weight by value means numerator it will be weight and denominator it will be the value. So mass of solute by volume of solution. Volume of solution. Fine. This will be like if it is in gram, it will be in ml into 100. Fine. And the seventh concentration term is this percentage weight. Here we have talked about weight by weight, weight by volume, and the next one is volume by volume, right? Sorry, volume by volume. This is V. Fine. Here the volume of solute by volume of solution into 100. So these are the concentration terms. And one more thing is there, that is parts per million or something, uh, which is, I'll also explain that thing. So this is ppm, parts per million. Parts per million. What does that mean? It indicates parts of solute per million parts of solution. So I hope you have understood. It indicates that parts of solute per million parts of the solution. Fine. So generally there are three types of formulas, like ppm by mass will be mass of solute, in grams, or if it is in grams, like in denominator, mass of a solution should be also in grams. Fine. Mass of solution into and into, it's not 100. Fine. It's 10 power 6. We'll multiply with a factor 10 power 6. Okay. So parts per million by value means volume of solute by volume of solution into 10 raised to power 6. Parts per million by weight by value means like in numerator we'll get mass of solute, and in the denominator we'll take volume of solution as we took over here. So and we'll just multiply with 10 power 6. So these are the concentration terms that you need to know and which are really important. So just try to just try to write it down once, and practice few questions based on these formulas, and try to correlate all these terms. So just let me know the answer for this question in the comment section. In which of the following which of the following matlab these concentration terms, which of the following concentration terms are temperature dependent? Temperature dependent, and why? Just tell me. And the one more question I'll give you. Just try to find out the correlation between the molarity and concentration. Like how can you find the molarity if they give concentration? Okay. Try to find out the relation between these two, and tell me which of the following are temperature dependent and why, and which are not and which are temperature independent. Fine. So yeah, this is all for this particular video, and if possible, I'll make one more video and I'll explain these two questions. At the same time, I'll explain different topics which you need to understand. Okay, fine. And yeah, all the best for your preparation. Just don't take that much stress. You just study. I mean, you just don't try to mug up all the stuff. Try to understand the subject. Fine. When you try to understand the subject, then it will become easy and that subject will become your favorite. Alright. And when it comes to chemistry, if you understand the topics, then it will be easy. Just so yeah, that's it for this video, and if possible, I'll make one more video soon. Till then, just take care of yourself, and if there is any possibility of helping any somebody, just do that and take care of yourself and be kind. Okay, thank you. Bye.